स्लाइड प्रेजेंट हो रहा है? यस और नो? नो। स्लाइड प्रेजेंट हो रहा है?
Yes, sir.
ओके ओके। ठीक है। अच्छा, एक बार सिलेबस में देख लो क्या क्या छूट गया। ऑप्टिकल एक्टिविटी हो गया, इनर्शिया, डायस्टेरियम एंड मिजो कंपाउंड, चार हो गया था। एलिमेंट ऑफ सिमेट्री, कायरल एंड अकायरल मॉलिक्यूल। ओके, एलिमेंट ऑफ सिमेट्री आज बोल दूंगा क्या होता है। व्हाट इज एलिमेंट ऑफ सिमेट्री? कैपिटल डी एल सिस्टम हो गया था। सीक्वेंस रूल उतना इम्पोर्टेंट है नहीं। आर एस हो गया था, ऑप्टिकल आइसोमेरी हो गया था। रिएक्शन ऑफ कायरल मॉलिक्यूल, हाँ उसको मैं बोल दूंगा। रिएक्शन ऑफ कायरल मॉलिक्यूल, रासायनिक मॉडिफिकेशन, रेजोल्यूशन, एसिमेट्रिक सिंथेसिस। ओके, तो रेजोल्यूशन एंड रेजोल्यूशन ऑफ रासायनिक मिक्सचर, इसके बारे में थोड़ा सा बोल देता हूँ। तो पहले तो बोल लो कि व्हाट इज रासायनिक मिक्सचर, उसके बाद पढ़ेंगे व्हाट इज रेजोल्यूशन। बोल दो जिसको आता है, बोल दो व्हाट इज रासायनिक मिक्सचर। बोल दो तो जल्दी बोल दो, जिसको भी आता है बोल दो। किसी को नहीं पता?
Equimolar mixture of two enantiomers जिनकी
इक्विमोलर,
कोई ऑप्टिकल एक्टिविटी नहीं होती सर।
हाँ ठीक है। एंड व्हाट इज द प्रॉपर्टीज ऑफ enantiomer? Properties means uh, if you have two enantiomer, then their physical substance, then their chemical property will differ. Okay, suppose you have two enantiomer, so their physical property as well as chemical property, I mean their chemical reaction, everything will be exactly same. But when they are trying to bind with any type of enzyme or any types of receptor, I mean when, when we are using an enantiomer as a drug, So in that situation, they are they will act differently. अब देखो, suppose you have two enantiomer. So suppose you have uh, I mean one enantiomeric pair. Okay. So what will happen? And so what is the relation between these two compounds? They are same or enantiomer or diastereomer. Are they same or enantiomer or diastereomer? जल्दी बोल दो. कौन बोलेगा? कौन बोल रहा है? कोई भी बोल दो. Are they same or diastereomer और enantiomer of each other? क्या होगा? रिलेशन क्या होगा दोनों मॉलिक्यूल, मॉलिक्यूल ए एंड मॉलिक्यूल बी? जो लगता है बोल दो, जिसको जो लग रहा है बोल दो. आप कैसे ये सब तो सुनाई दे रहा है मेरे बात? हमें ऑडिबल टेप डाउन. चलो चुप क्यों हो गए?
Yes, sir.
हाँ अब बोलो क्या होगा दोनों के बीच में रिलेशन? जो भी आता है बोलो, जितना भी आ रहा है बोलो, जैसे भी लग रहा है. जो मैंने ट्रिक बताया था उनको फॉलो करो. स्टेप बाय स्टेप जो मैंने ट्रिक लिखा था ना, उनको फॉलो करो. ट्राई करो, जब तक ट्राई नहीं करोगे तब तक कुछ नहीं होगा. कन्वेंशनल मेथड को छोड़ दो अभी. उनको तो पहले 3D में आपको कन्वर्ट करोगे, फिर RS निकालोगे, उनको छोड़ दो, लेंदी हो जाएगा. जो मैंने ट्रिक बताया था बस उसको फॉलो करो. क्या होगा जल्दी बोलो, क्या लगता है?
Sir, molecule B ऐसे.
हाँ क्या होगा? ए एंड बी.
Sir, B ऐसे और A R है.
बी एस है, ए आर. बी में तो ऑलरेडी दो कार्बन है ना, तो ओनली ओनली एस कैसे हो जाएगा? दो पैरल कार्बन है.
Sir, लास्ट वाले कार्बन की बात कर रहे हैं.
अच्छा बी का लास्ट वाले कार्बन मतलब जो मैं सर्कल किया है, सर्कल वाला.
Yes, sir.
तो उससे क्या होगा? मैं क्या पूछ रहा हूँ? मैं पूछ रहा हूँ व्हाट इज द रिलेशन इन बिटवीन मॉलिक्यूल ए एंड मॉलिक्यूल बी? आर दे सेम और दे आर enantiomer of each other?
Sir, they are enantiomer of each other.
आर एस निकलने का जरूरत नहीं है, आर एस से करोगे तो लेंदी हो जाएगा बहुत. स्टेप को बस फॉलो करो. फर्स्ट स्टेप क्या था? to check that whether these two molecules are mirror image of each other or not. क्या होगा? Are they mirror image? Yes or no?
सर मिरर इमेज है, प्लेन ऑफ सिमेट्री नहीं है तो इनएंशियोमर है।
ठीक है। They are enantiomer. अब क्या होगा? As they are enantiomer, so their physical property as well as chemical properties will be same. Okay. For diastereomer, chemical properties are same, but physical properties are different. Okay. So in that case, both chemical as well as physical property will be same. Now, how can you differentiate these two compounds? I mean, you have a racemic mixture in which molecule A and molecule B both are present in equimolar quantity. Okay. So now if someone is saying you, someone ordered you to separate these two molecules, I mean molecule A from molecule B, then what will you do? Because their physical property is exactly same. So if you hit this racemic mixture, then will also be same. Okay. In a
They differ in
different
the
if
direction in which they rotate the plane polarized light.
हाँ तो उससे क्या होगा? How can you separate them? Someone is saying you to separate these two molecules. I mean, in a beaker, you have molecule A and molecule B in equimolar quantity. So you have to separate molecule A from molecule B. So what will you do? This process is called resolution. Yes, they will rotate plane polarized light in opposite way. But how can you separate them? Their solubility is exactly same. Their melting boiling point or any other type of physical property, chemical property, everything is same. So how can you separate them? If you have a diastereomeric pair, I mean, if you have C plus D, where C and D are diastereomers with each other, okay, if you have two molecules C and D, and C and D are diastereomer each other, so in that case, you can easily separate them out. Why? Because they have different physical property. Suppose C has boiling point 100 degree and D has boiling point 50 degree. So by vaporing them out, you can easily separate them. Okay. But problem creates when two molecules are enantiomer with each other. They have exactly same physical property as well as chemical property. So in that case, how can you separate them out? Are you getting my question?
Yes, sir.
So this process is called resolution. So in resolution, what will you do? You need to first convert this in an enantiomeric pair into diastereomeric pair. Okay. First, you need to convert this enantiomeric pair into diastereomeric pair. Suppose I'm taking an easy example. Okay. I'm taking an easy example like What will be the this carbon is R or S? क्या होगा? It's just R or it is S? बोलो. अच्छा दोनों OH ऐसे हो गए यहाँ पे. Sorry, sorry. It will be CH3, not OH. Okay. Otherwise, this molecule will become achiral. For chirality, four groups should be different. So for molecule A, this molecule will be 1, 2, 3, S. Okay. This molecule will be S. And molecule B will be molecule B. गलत लिखा दिया. गलत लिख दिया ना. दोनों मॉलिक्यूल सेम हो गया. दोनों मॉलिक्यूल सेम कर दिया था मैंने. अच्छा जो पहले वाला एग्जाम्पल था ना उससे भी एक बात आप सीख सकते हो. देखो मॉलिक्यूल बी इज ऑल्सो एस. दिख रहा है ना. काउंट करके देखना. तो दिस two molecule are looking different but they are same. Why? Because the chiral carbon has same orientation for both of this carbon. The chiral carbon has S stereochemistry, so both of these molecules are same. Okay, so I'm just changing this molecule, changing the side atom like bromine and OH. Now this molecule will become R. The second molecule will become R. It is not S right now. So these two are enantiomer of each other. Any problem till now? Any problem?
No, sir.
So these two molecules, I mean molecule A and molecule B has exactly same chemical properties, same physical properties. So how can you separate them out? So what I have told you that first you need to convert these two molecules into a diastereomeric pair. Okay, so how can you convert them into diastereomeric pair? Any idea? You
By
can
adding
attach
pure reagent.
by adding what?
Pure reagent.
Pure reagent. What is the meaning of pure reagent and unpure reagent?
Sir, it is a resolving agent.
Resolving agent or reagent? What was saying? Agent or
Resolving agent which can convert a racemic mixture into diastereomers actually.
so what is resolving agent? Any example?
No, sir, I don't have any example right now, but
Okay, resolving agent mean which need to be chiral. Okay, resolving agent mean
yes,
which need to be chiral like CH, CH3, Cl, COOH. So is this a chiral molecule or a chiral molecule? This green molecule, is it chiral or achiral?
chiral, sir.
Okay, then what will be the stereo? I mean, it is R or is it S? Stereo configuration. What will be the stereo configuration of this chiral carbon? Is it R or S? The fourth group is on the plane, so you need to increase your imagination power. Okay.
S, sir.
Yes. How?
Yes. So chlorine is 1,
Then.
COH is 2,
Hmm.
and CH3 is 3.
uh, then
Also, we need to invert the configuration because chlorine is below the plane.
chlorine is below the plane, COOH is on the plane, and CH3 is above the plane. Okay.
Yes,
And
sir.
from which side you should look? You can't look this molecule from this side. Why? Because if you are watching this molecule from right hand side, then hydrogen will be just in front of you. Okay. So you need to look this molecule from this side, this angle. Okay. Now hydrogen will be away from your viewing side. So now just imagine chlorine, COOH and CH3. The rotation is like this. Okay. So it will be R, not S. Any problem?
No,
What I
sir.
have told what I have told you in the first
Sir,
class
when
that
do we need to invert the configuration?
when you need to
When do we need to invert the configuration?
see if you have strong imagination power, then you don't need to convert this configuration. Okay. Try to increase your imagination power. Always remember that the fourth group should be away from your viewing side. Okay. Fourth group should be away from your viewing side. And then try to observe the rotation 1, 2, 3. 1, 2, 3 is clockwise or anti-clockwise. 1,
No, sir,
2,
but what
3.
you are doing is in some compounds you are using the different plane of eye. मतलब आप दूसरी जगह से देख रहे हैं, आप eye को कहीं और बना रहे हैं, observation दूसरी जगह से कर रहे हैं. But in some compounds आप
हाँ.
वो observe करके नहीं दिखा रहे हैं, आप directly बता रहे हैं कि हाँ चलो ये R है, ये S है.
हम्म.
तो
देखो
कैसे पता
अगर
चलेगा कौन सी
हाइड्रोजन
मॉलिक्यूल में हमें अपना
हाइड्रोजन
आई
अगर
मतलब ऑब्जर्वेशन कहीं और से करना है.
नहीं अगर हाइड्रोजन अगर above the plane और below the plane है ना तब तो कोई प्रॉब्लम नहीं है. If hydrogen is above the plane or hydrogen is I mean fourth group not hydrogen, it may be any group. If fourth group is present above the plane or below the plane, then you don't need to think about anything. Just observe the rotation of 1, 2, 3, and accordingly you can name it. Okay. If fourth group is above the plane, then you need to revert the order. Okay. Like 1, 2, 3, and fourth group is above the plane, then rotation will be like this. It will be S. Okay. And if fourth group is below the plane, then it's okay. If 1, 2, 3 is clockwise, then it will be R. If 1, 2, 3 is anti-clockwise, then it will be S. So there is not any type of problem. But when fourth group is just on the plane, so in that case, you need to increase your imagination power. I mean, you need to change your angle of viewing. Okay.
So,
Any
so basically
problem?
it applies only on the compounds on which the hydrogen or the last fourth group is on the plane,
Uh,
right?
uh, on the plane. Okay, yes, on the plane. Otherwise, you don't need to think about anything. Okay,
Also, sir, in compound B, the hydrogen is below the plane. So
below the
what
plane.
you
Yes.
told us in previous classes is if the configuration
Like
is R,
one,
you
two.
need to change it to S.
No. Hydrogen is below the plane, so the configuration will remain same. Like one, here see 1, 2, 3 is like this. 1, 2, 3. So it will be simply R. If hydrogen is below the plane, then it will be simply R. And for the molecule A, the stereochemistry of this chiral carbon will be S. Okay.
Yes, sir.
Any problem? See, now what will happen?
No, sir. No, sir.
So what will be the product of acid and alcohol? Although, what will be the product of acid and alcohol? Any idea? It will be ester. Acid
Easter.
plus alcohol means ester, yes. So molecule A, which is molecule C, okay. So molecule molecule A after reacting with molecule C, the product will be like this. ClH and CH3. Okay, and molecule A plus C and molecule B after reacting with molecule C, the product will be like this. Any problem? CH3O, then ClH and CH3. So now what happens? Molecule A plus C, the stereochemistry of molecule A plus C will be SR. Okay, SR. For molecule B plus C, the stereochemistry will be RR. Okay. Any problem till now? Any problem?
No, sir. No,
SR
sir.
and RR. Okay. So last I have told you what is the relation in between SR and RR. What will be SR and RR? Any idea? जल्दी बोल दो. They will be diastereomer of each other. Okay, like RR with SR, or maybe SS with SR or RS. So those types of relation is called diastereomeric relation. Okay, याद रहेगा ना? RR with SR. Those types of relation is called diastereomeric pair. So now this molecule became diastereomer of each other. Okay, any problem?
No, sir.
So now they can be separated out. Why? Because they will have different boiling point or different melting point or different solubility. When their solubility also will be changed. Okay, the physical property will be changed. So according to the boiling point difference, you can separate them out. And what will you do after separating them out? And now in B card A you have A plus C, and in B card C you have B plus C. Okay, why? Because they have different boiling point, so they can be easily separated out. Now what will you do? Any idea? You want
For
molecule A
separating,
and
for
separate तो हो
separating,
गया.
we will do. Yeah.
But the final product should be molecule A and molecule B, because the starting product was molecule recipe mixture of molecule A and molecule B, and you want to separate them out. So now what you have to do? You need to remove this to a diastereomeric pair. So once the diastereomeric pair is formed, you can separate them out as they have different physical property. So now you have to remove molecule C. So how can you remove molecule C? Hydrolysis. You just need to do hydrolysis. I mean, if you are using acidic water, then what will happen? This ester bond will break. After breaking of ester bond from the mixture of molecule A plus C, you will get molecule A, and from the mixture of molecule B plus C, you will get molecule B. So now they are separated from each other. So any problem till now? Any problem till now?
No,
Resolution.
sir.
What is resolution? So can anyone quickly brief the whole process? What is resolution? सबका माइक्रोफोन ऑफ हो गया. कोई भी बोल दो. Brief idea. What is resolution? बाकी सबको समझ में आ गया. शिवानी को तो आ गया. बाकी सबको आया? यस एंड नो? फिर देखो नेक्स्ट. पूछ लो, अभी भी पूछ लो, बाद में मत बोलना. कुछ प्रॉब्लम है तो पूछ लो अभी भी. ठीक है, देखो रेसिमिक तो हो गया. रेसिमिक मॉडिफिकेशन, रेजोल्यूशन हो गया. अब एलिमेंट ऑफ सिमेट्री में थोड़ा सा बोल रहा हूँ. ठीक है, व्हाट इज एलिमेंट ऑफ सिमेट्री? देखो कुछ नहीं होता एलिमेंट ऑफ सिमेट्री में. जितना आपको पढ़ना है एक्सेस ऑफ सिमेट्री. ओके, so there are so many types of axis of symmetry, but I think for your B.pharm syllabus, just try to understand what is C3 axis of symmetry and C2 axis of symmetry. Okay. So suppose we have molecule like this, 1,4-dichlorobenzene. Okay. Or is this a planar molecule, flat molecule, or non-planar? इतना तो पता होना चाहिए. Benzene is planar or non-planar?
Sir, planar.
Planar. So suppose you draw an axis like this, okay, and you rotate this molecule 180 degree. You rotate this molecule 180 degree. Then what will you get? Exactly same molecule. After Suppose this is chlorine 1 and this is chlorine 2. So after 180-degree rotation, what will you get? You will get exactly same chlorine 2 upside and chlorine 1 downside, but there is not any difference between chlorine 1 and chlorine 2. Okay, those are not isotopic pair. Those are simple chlorine. Okay, so after rotating this molecule 180-degree, you are getting exactly same molecule. So these types of rotation around the axis is called C2 axis of symmetry. Okay, so this axis will be called C2 axis. So 1,4-dichlorobenzene has C2 axis of symmetry. Now, how can we calculate the value of N and Cn? So here N is 360 by 180. Okay, it is 2. Let's see another example like NH3. Okay, what is the hybridization of NH3? What is the hybridization of NH3? I mean N molecule. N
sp2 sir.
NH3. sp2. Why sp2? Is there any double bond? Is there any double bond present in NH3 molecule? Hmm?
No sir.
Then why? And then how can it become a sp2? It is sp3, not sp2. Okay, the structure is like pyramidal or tetrahedral shape. Okay, so if you draw an axis like this, then what will happen? If you rotate this molecule 60 degree, okay, if you rotate this molecule 60 degree, then what will happen? You will get exactly same molecule. Okay, you will get exactly same molecule. Rotating this molecule 60 degree, hydrogen 2 will be in this. Only the hydrogen will change their position. Okay, there will be hydrogen 1 and there will be hydrogen number 3. Any problem?
No sir.
But all of them are hydrogen. Okay, they are not deuterium or tritium. Okay, all of them are hydrogen. So hydrogen 1, 2 and 3 all are same. So after rotating this molecule 60 degree, you are getting exactly same molecule. So now N value will be 360 by 60 equals to what?
6 degrees sir.
Actually, I am saying wrong. मैं गलत बोल रहा हूँ, कोई कुछ बोल भी नहीं रहा है. मतलब सब लोग सो रहे हैं, प्रूव हो गए. मैं तो गलत बोल रहा हूँ, गलती तो पकड़ो. क्या गलत बोल रहा था मैं? 1, 2 एंड 3 के बीच में एंगल कितना होगा? 60 थोड़ी होगा. मतलब आप अगर ऐसे कर लो 1, 2 एंड 3 नीचे मान लो ट्रायंगल, ठीक है. यहाँ पे हाइड्रोजन 3, हाइड्रोजन 2, हाइड्रोजन 1 एंड हाइड्रोजन 2, ठीक है. तो एंगल कितना है? सॉरी, मैं कुछ गलत बोल रहा हूँ क्या? रुको रुको रुको. बाहर का एंगल तो 60 होगा, इसका रोटेशन कितना हो रहा है? हाइड्रोजन 1 को आप क्या कर रहे हो? हाइड्रोजन 2 पे लेके आ रहे हो, हाइड्रोजन 2 को 3 पे लेके आ रहे हो, हाइड्रोजन 3 को 1 पे लेके आ रहे हो. So what is the rotation? This angle is not 60. This angle is 120 degree. Any problem? if you are rotating this molecule along this axis, along this red axis, 120 degree, not 60 degree, 120 degree, then only you will get exactly same structure. Hydrogen 2 will be replaced by hydrogen 1, hydrogen 3 will be replaced by hydrogen 2, and hydrogen 1 will be replaced by hydrogen 3. Only you will get the same structure if you are rotating this molecule along this red axis via 120 degree, not 60 degree. Any problem? समझ में और डाउट है? जल्दी बोलो. The rotation should be 120 degree. देखो, all this angle are 120 degree. This not 60 degree. Like nitrogen. जल्दी बोलो. Any problem?
No, sir.
Okay. So now n value will be, what will be the n value? 360 by 120. So 3. That means ammonia NH3 has C3 axis of symmetry. Okay. Any doubt?
No, sir.
बस इतना ही पढ़ना था. C2 C3 और भी बहुत सारा होता है, लेकिन B.pharm में जरूरत नहीं है उतना सारा पढ़ने की. और क्या छोड़ गया सिलेबस पे? ओके. नंबर ऑफ स्टेरियो आइसोमर पूछ रहे थे ना पिछले दिन, कोई तो पूछ रहे थे. व्हाट इज द नंबर ऑफ स्टेरियो आइसोमर? कौन कौन पूछ रहा था? अच्छा, जो भी हो, आप लोग देख लेना. ज़्यादा पढ़ने का जरूरत नहीं है. मतलब इसमें तो बहुत सारा फॉर्मूला आ जाएगा, लेकिन if any molecule does not has plane of symmetry, okay, if any molecule does not have any plane of symmetry, that means unsymmetrical molecule like CH3CHOH, CHOH, and then CH3 CH2 CH3. If this molecule has any plane of symmetry, no plane of symmetry, that means unsymmetrical molecule, and it has two chiral carbon, okay, two chiral center. So for those types of molecules, number of isomer will be 2 to the power n. So here 2 to the power 2, that means 4. Okay, number of isomers. Then all of them will be optically active. That means enantiomeric pair. Enantiomeric pair. Okay.
Yes, sir.
And the problem तो होगा ना. Problem will create when they have symmetry. When molecule have symmetrical in nature, I mean when symmetry is present, then the formula become complex. Okay. So in that case, if n is odd or maybe n is even, n mean, what is n? What is n?
Number of chiral carbon.
Number of chiral carbon. Yes, it is a number of chiral carbon. So if n odd for symmetric molecule, if n is odd, then number of stereoisomer will be 2 to the power n minus 1. Okay. And Okay, there are some separate formula, but that will be very much complex. So, do you really want to know that how much molecule will be optically active and how much molecule will be meso? Okay, I will tell them later. Okay, and if n is even, then what will happen? If n is even, then total number of stereoisomer will be 2 to the power n minus 1 plus 2 to the power n by 2 minus 1. Okay, that will be optically active and that will be optically inactive. Okay, so any doubt till now?
No, sir.
Yes, that is enough. And another thing, do you guys have any idea about chair form, boat form, or cyclohexane? Like you are drawing this cyclohexane like this. This is not benzene. Okay, benzene is planar, but cyclohexane is not planar. It can exist either chair form or maybe boat form, or sometime maybe twisted boat form. Okay, twisted boat form is very much difficult to draw. I can draw it. Check them in Google. Okay, 1, 2, 3, 4, 5, 6. Just forgot about it. Mainly there are two types of structure. One is chair, another one is boat. Okay. Okay. So those are not in your syllabus. So I'm just skipping them. Okay. That's all for today. So almost unit 1 is completed. Okay. From unit B, there is geometrical isomerism, cis trans configuration. Okay. In Newton, cyclohexane. Okay, so in unit 2, I will discuss about this chair and boat formation. Okay. So,
Sir, reactions
what
of
now?
chiral molecule.
Reaction of chiral molecule is also there.
Sir, inversion, retention.
Okay, okay. Inversion iteration. Okay, next I'll discuss it and then I'll start unit 2. Okay. Or maybe medicinal chemistry. I'll start medicinal chemistry next time. Don't leave right now. Don't leave.